Okay, let's learn how to solve a system of three linear equations. Linear just meaning the variables are to the first power. And we're going to solve the systems using elimination and back substitution. So let's look at an example of what this looks like. Say we want to solve the following system. So the first equation in three variables is x minus 2y plus 3z equals 11. The second one is 4x plus 2y minus 3z equals 4. And last we have 3x plus 3y minus z equals 4. Okay, so let's talk about what we're trying to do here when we say solve. We're trying to find ordered triples. So all an ordered triple is, it's like an ordered pair but in three dimensions. So ordered triples are an x value followed by a y value followed by a z value. So we're trying to find any xyz combinations that make all three equations true. So we're trying to find an ordered triple that satisfies all three equations. Okay, and for the purposes of what I'm teaching in this video, most of these systems will have exactly one ordered triple that makes all three equations true. Sometimes there are no ordered triples that make all three equations true. Sometimes there's an infinite number of ordered triples. We're going to focus on the most common case here though, where you get one ordered triple. Alright, so let's talk about the strategy here. So our goal is to come up with an equivalent system that has the following structure. So the first equation we're going to have x, y, and z still. The second equation though, we don't want an x, we just want the y and z. In the third equation we don't want x or y, we just want the z. Okay? So we want this sort of structure here in the end. And kind of what you see here is a stair-step effect on the left side of the equations. So you've got nothing for x here, nothing for x here, nothing for y here. Okay, so that's the elimination part. We need to eliminate those three things. And then once you've got your system set up like that, you do what's called back substitution. So for example, your third equation now has one variable, z. You can figure out what z is. Solve that equation for z. Figure out what number it is. And that will be the part of the ordered triple. Then you substitute that value in for z into your second equation, and then you can solve for y, and you'll get that part of the ordered triple. And then once you know y and z, you substitute those in to the first equation, and you can solve for x, narrowing down your x, y, and z values for your solution. Okay, so that's the general strategy. Now let's talk about how to do this. Here's what we're going to do. You work by columns, okay? So the first thing you want to do is use the x in the top left corner to eliminate the x in the second row and the x in the third row. Okay, so the way to do that is through row operations. And I'll show you some examples of these. So the first thing I'm going to do, I'll use blue for example. I'm going to take this x and I want to use it to eliminate this 4x. So the way to do that is I can multiply this row 1 is what I'll call it by negative 4. So I'll take negative 4 times row 1, and then when I do that I'll multiply both sides of this equation by negative 4. Okay? So what that looks like is if I multiply row 1 by negative 4, I get negative 4x plus 8y minus 12z equals negative 44. So that's my negative 4 row 1. And then I want to add to that row 2. Okay? So I'll copy my row 2 underneath 4x. Sorry, let me use red here. 4x plus 2y minus 3z equals 4. So I've got my negative 4 row 1 and my row 2 written down. Then I need to add them. So I'll put a plus out here. And then I'll add those together. Okay? Now what's the goal here? Our goal is to eliminate this 4x. And you can see that when I add these together, my negative 4x and my positive 4x will cancel. Okay, so I multiply my row 1 by negative 4 so that my negative 4 and positive 4 would cancel there. And we're going to add these in a second. But the idea is, whatever the result of this is, I want that to be my new row 2. So I'm going to be getting rid of the existing row 2 and replacing it with a new row 2 where this 4x is gone. Okay, so let's go ahead and add these together. So negative 4x plus 4x is 0, so those cancel. 8y plus 2y is 10y. Negative 12y minus 3z is negative 15z. Negative 44 plus 4 is negative 40. So that's my new row 2. Okay, and you can see my new row 2 won't have an x in this entry because there's no x here in my new row 2. Now, you could certainly use this as your new row 2, but if you notice, every number here is divisible by 5. So I could divide both sides of the equation by 5 just to make the numbers smaller and easier to work with. So that'll actually give me 2y minus 3z equals negative 8 for my new row 2. Okay, so that's going to be my new row 2. Okay, so let me write an equivalent system as we go along here. So row 1's not going to change. Row 1 has x, y, and z, so I'll leave him there. X minus 2y plus 3z equals 11, didn't change. But my new row 2 is what we just figured out. Positive 2y minus 3z equals negative 8. Notice that I'm keeping my x column, my y column, my z column, and my equals column all lined up the best I can. That helps a lot. Alright, we need a new row 3 also. So now what we're going to do is get a new row 3, and we're going to use the same x from row 1 to eliminate the x in row 3. So since this has a positive 3x, I want my x on the first row to be negative 3x. So I'll take a negative 3 times the existing row 1 and add it to my row 3 to get my new row 3, because I'm trying to replace my row 3 with a better version. Okay, so what that looks like, I'm going to look at negative 3 row 1. That's going to be negative 3x. I'm multiplying row 1 both sides by negative 3. So negative 3x plus 6y minus 9z equals negative 33. And then I need to add to that row 3, so I'm just going to copy row 3, 3x plus 3y minus z equals 4. And then I need to add those together. My x's cancel, which is what I wanted to happen because my row 3 I don't want to have x. 6y plus 3y is 9y. Negative 9z minus 1z is negative 10z. And negative 33 plus 4 is negative 29. So that's my new row 3. Okay? So I'll copy my new row 3 and get 9y minus 10z equals negative 29. And you can see now these guys, rows 2 and row 2 and row 3, do not have an x term. Okay, so now we proceed. Now I want to get rid of the y term in row 3 because I want that stair step effect here. So now the way to do that is we move over to column 2. We move over to column 2, and now we use this guy to eliminate this y. Okay, now this is a little trickier. I need those to be the same number but one positive and one negative. So the coefficients are 2 and 9. If I can make one of those 18 and one of those negative 18, that would do the trick. So there are many ways to do this, but for this video what I'll do is I'll take 9, how about negative 9 times row 2 right? Because now I'm using row 2 to eliminate row 3. So negative 9 times row 2 plus 2 times row 3. And I want to replace row 3, so this will be my new row 3. Okay? So negative 9 row 2. I need to multiply row 2 by negative 9. It's going to give me negative 18y plus 27z equals 72. And I'll add to that 2 times row 3. So I'll take row 3 times 2, which is positive 18y. You can see these are going to cancel, which is what we want. Minus 20z equals negative 58. And I need to add those together. So these guys cancel, and then I get 7z equals 14. And again, both sides here are divisible by 7, so I'll go ahead and divide both sides by 7. So I get z equals 2. Okay? So that's my new row 3. So let's rewrite our system. Row 1 didn't change. X minus 2y plus 3z equals 11. Row 2 didn't change. 2y minus 3z equals negative 8. And row 3 is new. Z equals 2. And now we've got our system in the form that we want. Okay, we got the stair step with all the elimination done. Now we need to do the back substitution. Starting from the bottom. It's called back substitution because you start at the end. So we know that z equals 2. So we're done. We know the z value. We need to find the y value, then we need to find the x value. So what I'll do is z equals 2 needs to be substituted into row 2. So that's going to turn into 2y minus 3 times 2 is 6 equals negative 8. And now you can see that y is my variable, the only variable I have, so I can solve for it. So I'll add 6 to both sides. Negative 8 plus 6 is negative 2, and divide both sides by 2 gives me negative 1 for y. So now I have my y value. Now I back up and I go to row 1 and I substitute these guys, z equals 2, y equals negative 1, into row 1. So let me copy row 1 back down. X minus 2y plus 3z equals 11. And then I plug y and z in. So I get x minus 2 times negative 1 is negative 2 plus 3 times z, so 3 times 2 is 6 equals 11. And now I can solve for x. So I've got minus negative 2 is plus positive 2. So I've got x plus 8 equals 11. Subtract 8 and I can see that x equals 3. So now I know x, I know y, and I know z. So the solution to that original system is the ordered triple where x is 3, y is negative 1, and z is 2. That is the only ordered triple, x, y, z values, that is the only ordered triple that makes all 3 of the original equations true. Okay? So the key to this is to really take your time, show your row operations. That's critical. Don't skip showing your row operations. In fact, I would encourage you to write out the new rows when you multiply and then add. That way you don't mess anything up. These are problems where it's truly faster to go slower. If you take your time and show your work, you're less likely to make a mistake and be able to finish the problem. If you hurry through it, you're very likely to make a mistake and get it wrong, and then you're not going to be able to find your error that way either. So you're going to have to start over again. So it's truly better to go fast or go slower on these types of problems.